We want to solve these simultaneous equations. The first equation is quadratic, and we can spot this because of the x times y. The second one is linear, and we can spot this because it can be rearranged into the form y equals mx plus c. The approach is always to take the linear equation and rearrange it so that one of the letters is the subject of the formula. So subtracting 4x from both sides gives us this, and then dividing both sides by 3 we get 29 minus 4x over 3. This can then be substituted into equation 1. So we write down the x, and instead of y we write down this expression 29 minus 4x over 3, and that's equal to 14. Multiplying both sides by 3, we get x times 29 minus 4x equals 42. Expanding, 29x take 4x squared is equal to 42. And for a quadratic we want everything onto one side, so we get 4x squared minus 29x plus 42 equals 0. This factorizes into two brackets. We could have 4x and x, 21 and 2, and if they're both minuses we get our 4x squared plus 42, take away 21x, take away 8x gives us minus 29x. So our solutions, x is 21 over 4 and x equals 2. We need to find the corresponding y values, substituting 21 over 4 into the expression for y. We get 29, take away 4, times 21 over 4, all divided by 3. The 4's will cancel here, so we end up with 29, take away 21 over 3, which is 8 over 3. Using x equals 2 in this expression, we get 29 take away 4 lots of 2 over 3, which is 29 take away 8, or 21 over 3, which is 7. So our solutions are x is 21 over 4, y is 8 over 3, or x is equal to 2 and y equals 7, and of course these should be checked in the original equations. As we've seen before, simultaneous equations can be solved graphically. Here we have a graph representing the simultaneous equations we've just solved. The red curve is the curve xy equals 14, and the blue line is the line 4x plus 3y is equal to 29. The solutions to the simultaneous equations are given by the points of intersection, which could be read from the graph.